S into H1 of S, and loop gain G4 of S into H2 of S. You can see this, and G4 of S, H2 of S is non-touching loop, is what is a non-touching loop gain taken two at a time. Very clearly. So these are two non-touching loops. The loops are not touching each other. There are no nodes in common in this case. So their loop gains, this and this loop gain number, this and loop gain this, is a non-touching loops which are taken two at a time. In summary, we can say, in summary, all three of the non-touching loop gains taken two at a time, are, what are they? Number one, G2 of S, H1 of S multiplied, we have to product them, multiplied by G4 of S, H2 of S. Number second will be same, because this is not common with another also, H1 of S multiplied by G4 of S, G5 of S, and H3 of S. Okay, last, this is G4 of S, G5 of H3 of S. That I have told you already, loops. So no need to repeat that. So last is G2 of S into H1 of S multiplied by G4 of S, G6 of S, and H3 of S. This is all combinations we have. Non-touching loops, product of the non-touching loops taken two at a time. They are not touching, and this is the maximum combination we can have. This loop is not touching with all the three loops. So this is this combination with number one, this combination with number two, this combination with number three. That's product of this loop with all other three loops. So this is, well, in this case, we don't have any non-touching loop gains. The product of loop gains, sorry, yes, three at a time we can also take. So, but in this case, the product of loop gains like G4 of S, G5 as H3 of S, and G4 of S, G6 of H3 of S is not a non-touching. So if we somebody can think of this also, that let me write for you, the product of loop gains G4 of S, G5 of S, H3 of S multiplied by G4 of S, G6 of S, and H3 of S. This product of loop gains is not a non-touching, loop gain. Why it's not, Tanzib? Why this is not a non-touching loop gains?
सर इनका एक नोड है कॉमन.
Yes, that's clear. सिंस एक नहीं है, या नोड कोई भी कॉमन हो, दैट्स ऑल, वहीं वहीं पे wherever the node is common, the rule gets violated, and that's not a non-touching loop. So in this case, we can write, since these two loop gains have nodes in common. Nodes in common. So this should be very clear that somebody can think of, sir, ये क्यों नहीं है, ऐसा क्यों नहीं? So definitions have been told you. Since the nodes are common, so we need not to take it. It's also clear in our example that there will be no non-touching loops taken three at a time. Why roll number 6? Roll number 8. Roll number 8 is there. Roll number 8. Roll number 10. Roll number 10. उसको कंट्रोल सिस्टम मुझे लगता है बहुत ज्यादा आ गया अब. रोल नंबर 6 is also not there.
Yeah.
What your roll number 27 Rutba? 27 Rutba. She's also
अस्सलाम
not
वालेकुम सर।
there. Walaikum salam. Tell me the reason why in our example we can't consider three non-touching loops take three non-touching loop gains. Why will not consider three non-touching? There are no three non-touching loop gains.
सर क्योंकि
Why?
इसमें कॉमन आ रहा है ना, जैसे H3 इसमें कॉमन आ रहा है, इस वाले में इनमें
We don't
कॉमन
have
आ रहा
any
है।
three loops which do not have, they have a node in common. So we do not have any three loops which do not have any node in common. That means they are not touching each other. One loop is three loops are touching with each other, and one is isolated loop. So we can have only combination of non-touching loops taken two at a time. So we can write down it here for your information. In above example, there is no non-touching loop gains taken three at a time. Three at a time, since three non-touching loop gains do not exist. In this case, they don't exist because there are nodes in common. So only one with one loop, they don't have no nodes in common. That's why they don't exist in this case. So I hope this is very clear. Non-touching loop gains, what are they? Non-touching loops, what are they? So there should be no confusion. Let's move to the main objective, which is our objective. Our objective is, in this case, to see what is Mason's rule. Mason's gain formula, it's also called. Mason's rule is also one and the same thing. So let's focus on this. Now the transfer function, how we are going to write the, sorry. The transfer function C of S by R of S of a system represented by a signal flow graph is Now G of S will be C of S by R of S, that we know. So it will be summation K are paths. We'll see one by one what is this. Tk multiplied by Pk divided by delta. So let's see one by one what are these all. Now here I'll box this formula for you in the red. Very important, you have to memorize this formula. Very simple, not a difficult formula to memorize. Okay. So where we can see one by one what are different things. Where K is number of forward paths. So we have seen the definition of the number of forward paths. K is number only. We have to write 1, 2, 3. How many number of forward paths are there? So K is number of forward paths. Number of forward paths. Tk is the kth forward path. Tk is the kth forward path gain, that is Tk. That means suppose T1 is there, so we have to write the forward path gain for T1. K is equal to 1. K is equal to 2. T2, what is the forward path gain of that? So that means whichever the forward gain is there, we have to consider that in the formula. Okay. Then delta is just a second. Okay. Delta is 1 minus, sorry, 1 minus summation of loop gains plus 1, first it will be plus minus, formula is like that. 1 minus summation of loop gains plus summation of non-touching loop gains taken 2 at a time, taken 2 at a time, okay, minus summation of non-touching loop gains taken 3 at a time, then again plus summation of non-touching loop gains taken 4 at a time, then it will continue to be like this. Very clear what is delta? 1 minus, you have to take the sum of the loop gains, take the sum of the non-touching loop gains taken 2 at a time, minus sum of the non-touching loop gains, so on and so forth. This will continue. This is delta. Now delta K is very important now. Where is delta K in the formula? Yeah. Delta K, sorry, this is not PK, sorry. My mistake, sorry. This is not PK here. This is rather delta K. So this is delta K. So delta K, what is delta K? You have to understand it very clearly. Delta K is delta minus under root of loop gain terms in delta that touch the kth forward path. That means you have to take out from the delta those you have to take value of the delta will be there something that value from that delta you have to subtract the value summation of all those loop gains that are touching that kth forward path. Suppose somebody is touching that kth forward, that will not be taken, that has to be subtracted. So only those rest we don't have to touch. Yeah, in other words, we can also write, in other words, delta k is formed by eliminating from delta those loop gains that touch the kth forward path. It's a very simple thing. Or I will write down that also. Delta k is formed by eliminating from delta. That means we have to subtract that from the delta. Those loop gains, that are touching the kth forward path. Those loop gains that touch the kth forward path. This will be more clear in the numericals. Forward path. So that's all. That's all about the Mason's gain formula or Mason's rule. These things we have to remember, and this is the formula, and we need to implement this when we have a signal flow graph type of a transfer function. Later we will see how to convert that into signal flow graphs also. For the time being, we will do some numericals. Okay. Okay. The first, what we are considering here, first numerical is find the transfer function C of s by R of s for the signal flow graph in figure. Let's see. Signal flow graph is like this. Okay, I'm drawing the different nodes. Okay, so that's fine. Okay, that's all. This lines will be there. Another will be this one. Okay, then bigger will be, this will be bigger. This is joining this one. Okay, then there will be a small loop also. Okay, that's all. Well, let's draw the arrows first. This is one. Okay. Okay, these are the arrows. So let's write this is an input, this is your output. We are going to write first the Mason's formula, only the Mason's gain formula. For that, G1 of S, this is G2 of S, this is G3 of S, okay, this is G4 of S, and this is generally we are writing G4 of S. Just a second. Oh, this is wrong here. This is G5 of S. Actually, this is not here in the question. We'll just try it again. This is like this. Okay. Fine. So G5, this is your C of S. C of S is here. Then we are having G6 of S. Then we are having this G7 of S. As this is G8 of S. This is H4 of S. This is H1 of S. Okay, this is H2 of S. Okay, what is H3? This is H2 of S. Anyway, fine. H2, 3 of S is not there. It's not in the question, so we don't have to write it. I think this is the question. So we'll be looking into the solution of this one. What we have to find? We have to find the transfer function. Obviously, signal flow graph is given. So our preferable method will be, you can convert that into the block diagram also, but preferable method is Mason's gain rule. So first of all, what we are going to do, first identify the forward paths. That will be our first identify the forward path gains. In above example, there is roll number, who's there? रोल नंबर 46. जल्दी जल्दी, इतना टाइम नहीं है मेरे पास. रोल नंबर 16, बुरहान.
Yes, sir. Stick to number.
Okay. Tell me, how many forward paths are there?
Only one.
Which one?
G1, G2, G3, or G5.
That's all. There is only, so we can write there is only one. Identify the forward path skin in the above. There's only one. In this case, clearly there is one. So which one is this one? So Burhan has told G1 of S. Any other? Why there is not any other possibility? G2 of S, G3 of S, G4 of S. That should start from the input node to output node. That is clear. And second, it should be in the direction of signal flow. So it is in the direction of signal. No other path. So you can take this path, but that's not in the direction of signal flow. Okay, G4 of S and G5 S. So it's only one forward path gain we have. Number one, we have identified this. Second, so we can write it like this, step number one, which we need to do. Okay, now step number two. One by one step we have to do, and then we have to put them in the formula. Identify the loop gains. Identify the loop gains. Very good. How many loop gains are there? Roll number 8. जल्दी टाइम नहीं है इतना. Roll number 39. 39. Roll number 39.
Assalamualaikum, sir.
Okay, why you are not answering?
Sir, last class miss हुआ था इसलिए sir.
Okay, roll number 60. Rutba.
Assalamualaikum, sir.
Walaikum salam. Tell me, identify the loop gains in this case. Shabash, how many loop gains are there? जल्दी
Sir,
जल्दी.
3.
No, 3 नहीं है, 4 है. अच्छी तरह देखो. One is G2 of n H1 of s. Another is G4 of H2 of s. ठीक है. Another is G7. ये तो 3 हो गए. बड़ा वाला कहाँ जाएगा? ये भी तो लूप गेन है. अच्छी तरह देखना है. बड़ा वाला कहाँ जाएगा? वो भी तो लूप गेन है. Number 1, G2 of s H1 of s. Number 2, G4 of s H2 of s. Number 3, G7 of s. Everybody knows this loop gains. ये तो आसान है. Only last wall identify. The last way to identify is the bigger loop. This one. Okay. So loop gain number 4 is G2 of s.
तो इनको हमने फिर G से डिनोट क्यों किया, H से क्यों नहीं?
ये तो ट्रांसफर फंक्शन है ना. दिस इज अ ट्रांसफर फंक्शन. किसके बराबर होता है? सी ऑफ एस बाय आर ऑफ एस. इसको ट्रांसफर फंक्शन मेन को जीएस से और फीडबैक है. ये इसमें कोई फर्क नहीं है. मेन जैसे हम करते हैं ना वहां पर what you call it in a block diagram technique reduction. That's a transfer function, and then we have a feedback. This is a feedback gain. That's all. It doesn't matter at all. G3 of S. This is a notation of the main transfer function and the feedback gain. G5 S, G6 of S, G7 of S, and then G8 of S. So 4 loop gains are in this case. Step number 3. Step number 3 is identify the non-touching loops taken 2 at a time. Ab loop gains you have in front of us. You have to identify non-touching loops. Loops mean loop gains taken 2 at a time. Okay. So how many we have? We have named them loop 1, loop 3. How many we have non-touching? Loop 1 is not touching with loop 2. Loop 1 is not touching with loop 4. Loop 2 is not touching with loop 3. Sorry. 1 is not touching with 2. 1 is not touching with 3. 2 is not touching with 3. Okay. That's clear. So 3 pairs are possible, because others there is no possibility, because this is common to all other nodes. So we can say loop 1 does not touch with loop 2. Loop 1 does not touch with loop 3. Loop 2 does not touch with loop 3. So this combination of non-touching, you can write here loop 1 does not touch with loop 2, and loop 1 does not touch with loop 3. Okay, and then loop 2 does not touch with loop 3. Okay, so this is very clear. The combination of non-touching loops taken two at a time will be the combination of non-touching loops taken two at a time are as follows. So combination will be as follows. Let us see what's the combination now. Loop 1 and loop 2. You have to multiply the loop gain, that is G2 of S into H1 of S, G4 of S into H2 of S. So similarly, loop 1 and loop 3, G2 of S, H1 of S, G7 of S, H4 of S, loop 2 and loop 3, loop 2 and loop 3, that will be G4 of S, H2 of S, G7 of S, and H4 of S. So you have to see it from here. Loop gains we have written. 1 is not touching with 2. You multiply it. 1 with 3, 2 with 3. So 3 combinations are possible. Finally, non-touching loops taken 3 at a time. So next step number, you can write in next. Okay, step number 4. In this, we have only 4 possible steps. So that is non-touching just a second, yes. So next is non-touching loops taken 3 at a time. So we can clearly see loop 1, loop 2, and loop 3 do not touch each other. So loop 1, loop 2, we will multiply them. So loop 1, 2, and 3 do not touch each other. This is very clear. So we can multiply their gains, G2 of S into H1 of S multiplied by G4 of S multiplied by H2 of S multiplied by G7 of S multiplied by H4 of S. So that's a non-touching loops taken. So this is all we can do. There will be no possibility of having non-touching loops taken 4 at a time. That's not a possible. Only 4 loops because one of them are nodes in common with other 3. So this much we have to get first identify. Now let's apply the Mason's rule now. Okay, now let's apply the Mason's rule. From the Mason's rule, we have delta and delta K. We have to find delta and delta K. So let's see that. Delta will be what? Delta is very simple. 1 minus loop gains. So we have this one, loop gains. First, you can see step here. This is the loop gains. We can just multiply these loop gains together. So loop gains, we can multiply summation of all that we have to do. That's a formula. Summation is what? What is the loop gain number one? G2 of S. You have to write that. That's one. Plus second, G4 of S into H2 of S. Then third, G7 of S into H4 of S. Then last, G2 of S, G3 of S, G4 of S, G5 of S, G6 of S, G7 of S, and G8 of S. So this one we have done. What? Summation of the loop gain. Next, minus plus is the formula. Non-touching loop gain taken two at a time. So how many possibilities? We have seen three. We have to add those. So we will add this simply we have to add. See here, this. We have to add them together. So non-touching loops taken two at a time. So it will be G2 of S, H1 of S multiplied by G4 of S and then H2 of S. Okay, next plus G2 of S, H1 of S multiplied by G7 of S and here we can write H4 of S there only. Okay, then plus G2 of S, okay, G3 of S, that's loop gain number, G4 of S, then we have G5 of S, G6 of S, G7 of S, G8 of S, okay, multiplied with, sorry, just a second. We have got this loop, yeah. G2 first we have taken, no problem. Second we have also taken. Third is this combination, and that has to be, just a second, let's take them one by one like this. Yes, okay, fine. Now this is like this and this.
So third wala galat hai.
Just a second, I'm coming to that. Now first we have got this one. So second we have non-touching loops taken two at a time. So this is 1 and 2, G4. Okay. Next is, yeah, this is G7 H4, yeah, plus G7 H4. That's correct. So we don't have to write this. That's correct. G4. Just a second. Okay, put them in bracket if I think there is no problem. This one, okay, fine. So we have got these two, then minus. What is?
So एक और add होगा ना शायद. Loop 2 and loop 3.
Just a second. We have not written that. Yeah,
So
that
what?
will
G4 H2.
G4. Yeah, that is also there. There is तीन combination है 1, 2, 1, 3, 2 and 3. That's correct. So we have to write G4 of S, G4 of S, H2 of S multiplied by G7 of S and H4 of S. That's what's left. So that finishes these non-touching loops taken 2 at a time. So 1 is there also, non-touching loops taken 3 at a time, step number 4. So we can directly write that here. That is G2 just a second. I think हमने कोई गलती नहीं थी. G2, let me check it. This is 1 with 2. G4 of S, yes. 1 G2 of S, G 1 with 3 and 2 with 3. So that is fine. So last is what? Last what we have got? We have got these loop gains. We have taken them one by one. So last is non-touching loops taken 3 at a time. There is one combination. That is this one. We can write down this. So non-touching loops taken 3 at a time. G2 of S. थोड़ा ध्यान रखना है लिखने में क्योंकि इसमें ज्यादा प्रॉब्लम हो रहा है कि H1 H2 है. So numericals you will not get this H1. This is for the generalization I have shown. Numericals you will have values and that's very simple. G4 of S into H2 of S, okay, into G7 of S into H4 of S. So this is all we have. Beyond that, oh, this is delta. Now let's find delta K. Delta K is what? Delta K, I have told you simply. Delta K is formed by eliminating from delta the loop gains that touch the loop gains that touch the kth forward path. So let's see how we can find this. Okay, previous was a simple formula. You have to substitute it here. So delta 1, because why? There is only one forward path. So this is we have to find delta 1 only. Forward path gain is only 1. So there will be only delta 1. So how that will be? From delta 1, we have to, that will be written as 1 minus, so which is touching it. So this is touching it, this is touching it, and bigger one is also touching. Only leftover is G7 H4. So leftover is, I'm again repeating it. The kth forward path, that means forward path is only 1 here in this case. That means P1 we can write T1, some books write T1 forward path. So this forward path is 1 only. So loop number 1 is touching, loop number 2 is touching, and loop number 4 is also touching. Only the loop number 3 is not touching. So how we have to write it? What is the simple way to write it? The way to write is 1 minus G7 of S and H4 of S. So this is the way to write it. Then substituting this above values in the formula, substituting above values in the formula, therefore transfer function will be, so transfer function G of S, which is equal to C of S by R of S in general, will be T1 only one forward path, delta 1.
So delta K फिर से समझाइए.
Delta K, you should always remember that's 1 minus something. ठीक है, ये एक empirical formula है, we can't derive this. ये Mason ने दिया है. So how he has done it? Delta he has found 1 minus, तो आपको पता है, product of loop gains, summation of the product of loop gains, then plus product of summation of the loop gains, non-touching loop gains taken 2 at a time, minus and that 3 at a time, that will continue from there onwards. Delta K you have to find, see, you have to identify how many paths are there. So this can be T1 delta 1 plus T2 delta 1. But since there is T1 only, so there can be only delta 1. When there is T1, there will be only delta 1. So there is not possibility of delta 2. So delta 1, how we have to find? We have to eliminate from, you can have a look here. We have to eliminate from the delta. That means 1 minus all those loops that will be touching the forward path. There is only one forward path, G1, G2, G3, G4, G5. So loop number 1 is touching it, eliminate it, leave it. Loop number 2 is touching it, eliminate it, leave it. Loop number 4 is touching it, eliminate it, leave it. Touching means nodes are common. But loop number 3 does not have any node in common. So 1
तो फिर
minus that will be
फिर
considered.
एलिमिनेट तो फिर वो 3 होने चाहिए थे ना.
तो 3 तो किया हमने, किए ना. हम 1 माइनस खाली ये लिख रहे हैं ना, 1 माइनस G7. आपको फॉर्मूला में क्या लिखना है?
अच्छा ठीक है. नहीं मुझे
उनमें
लगा
से
आपने
फॉर्मूला
डेल्टा
में, लेट्स गो बैक. मुझे लगता है आपको समझ नहीं आया है. आर यू क्लियर और आर यू नॉट क्लियर?
सर अभी क्लियर है.
लेट्स गो बैक. सी हियर, डेल्टा में क्या निकालना आपको? वो सारे चीजें आपको खत्म कर देनी है. कौन से? जो कि टच हो रहे हैं. तो डेल्टा में हम यहां ले रहे हैं 1 माइनस ऑल दोज विच आर टचिंग. वी डोंट हैव टू कंसिडर. जो टच नहीं हो रहा है उसको कंसिडर करना है. वी हैव टू एलिमिनेट का मतलब तो वही होता है, उन सबको निकाल देना है. रेस्ट लेफ्ट ओवर इज ओनली थर्ड लूप दैट वी आर राइटिंग हियर. ओके, आई होप दिस इज क्लियर.
यस सर.
Now the formula becomes T1 delta 1. Why? Because there is only one forward path represented by T1. Delta 1 is only 1 divided by delta. So you can just directly substitute these values. So this values will be G1 of S into T1 is G2 of S, G3 of S, G4 of S into G5 of S. So that is T1 into delta 1 is 1 minus G7 of S, H4 of S divided by your delta. You don't need to write it in this type of question. You can simply write it delta. We know we have written delta. All those values we don't need to write. So this is the first numerical we have done just to become familiar with the Mason's rule. That's why I have taken the generalized values. Anybody who has a question can ask the question. Anybody who has not been able to understand the question, how we are taking the loop gains and then what's the forward paths, what's the non-touching loops taken 2 at a time, 3 at a time, what are the loop gains? Anybody who's still not clear, I can clarify it. Okay, I hope everybody's clear. So let's move to the problem number 2.
So उसमें 1 minus G7S क्यों आया?
1 minus हम generalize ये जो Mason लेता है, he's taking it, this is minus, he's taking the gain as 1 unity. That's what this is a delta minus. It's a type of delta minus. So that's why he's taking from this gain, he's eliminating all other and he's considering only the path में है ना ये, first path में है ना ये. So that's a unity gain we are taking here minus this loop gain which is not touching it. That's all. That's why we are taking 1 minus. Or rather, if you want to go it like, it will become very cumbersome. You can take it like delta minus loop gains that are eliminating. So you have to subtract that. It will exactly come out to be that loop gains that are delta K. What you have to do, delta minus all those loop gains which are touching it. You subtract it. You are going to get the same value. So to simplify that value, we are writing it equal to 1 minus only that loop gain which is not touching. Otherwise, you can also go for delta minus what? All those loop gains which are touching it, you subtract it, you are going to get the same result. It doesn't matter at all. Okay. Next is find the transfer function C of S by R of S for the control system signal flow graph Okay. Signal flow graph. For the control system signal flow graph shown in figure using Mason's gain formula. So we can find it. I'll draw the diagram. Sorry, it's red. Okay. Okay, just a second. Okay. Okay, just a second. Okay. Okay. Sleep. This. Okay. So jump connection here. So this is an input node. This is one here, R of S, and he has given it as input. This is one here, C of S as an output, minus H1 he has given it, minus H2. Okay, this is one here also. This is G2. This is G3. This is G4. Okay, this is G5. Okay, this is G1. This is G6. This is G7. ये तंजीब क्लास कितने बजे तक है?
सर 2:50 तक.
2:50. Okay, anyway, जल्दी जल्दी हम देख लेते हैं कुछ चीजें. We'll see. Okay, from this number one step, I think, yeah, this is the question only. Question is this much only, G1. Yes, I'll check the values. Okay, now solution of this is Number one step, what I have told you, forward path gains. Okay, forward path gains. K. K. Sorry. Roll number 3.
Yes, sir.
हाँ जी, but better tell me how many forward path gains are there. इसमें थोड़ा दिमाग चाहिए, देखना है. थोड़ा कन्वेंशनल क्वेश्चन के.
सर शायद 2।
बेटा आप दिमाग लगाओ थोड़ा. What you are talking about? There are much more than 2. एक तो मैं बता देता हूँ, ठीक है. जी ये एक है, फर्स्ट ये. देन वी हैव G2, देन वी हैव G4, ठीक है. देन वी हैव G6, दिस इज G6 here. And again input to, what is a basically forward path gain? हाँ बेटा जल्दी जल्दी, इसमें क्या है, जबानी बोलो. Why you are flipping the pages?
सर ये
It's a
प्रोडक्ट ऑफ गेन फाउंड
product of gains from input node to output node
आउटपुट नोड
in the direction of the signal flow graph.
सिग्नल
That's
फ्लो।
all. That's a very simple. So this is one I have told you. How many are there? Anybody, any volunteer? अभी जो क्वेश्चन पूछ रहे थे ना.
G1, G2, G4,
How
G1,
many?
G2, G1
Sir,
and G7.
No, you tell me the number. I don't need this G1.
सर
3.
उसकी
I guess
डायरेक्शन नहीं है एक
3
जो
और
मान
4
लो
सर,
जो
चौथे
बीच
वाले
में
को डायरेक्शन नहीं है ना.
कोई एक बच्चा बताइए हाउ मेनी नंबर्स आर देयर. मुझे डायरेक्शन वायरेक्शन कुछ नहीं चाहिए. आई
3,
नीड नंबर्स. हाँ,
3.
3 I guess.
दैट इज क्लियरली रॉन्ग. वी लीव इट टू द नेक्स्ट, तब तक कि आप घर में इसको सोल्यूशन देखिए, ठीक है. आराम से, ठंडे दिल से. ऐसे नहीं होता, ठंडे दिमाग से. दिमाग चाहिए इसका ठंडा, तो यू कैन यूज.
सर जो
बिल्कुल.
दूसरा डायगोनल है वो क्या है?
सर जो बीच में है उसकी डायरेक्शन
दैट्स, या दैट इज G8. सॉरी, हाँ आपको बोल गई.
सर उसकी डायरेक्शन की
देते हैं आपको उसकी डायरेक्शन. इसकी ऐसे है.
फिर 4
जी,
आएगी.
वही मैंने कहा ना, आप देख लीजिए. मेरे ख्याल से तो सारे आप गलत ही हैं अभी तक. ओके तंजीब, यू कैन सेंड द लॉग, ठीक है.
ओके सर. सर हो गया.
देन यू कैन लीव, आई विल सेंड इट. मैं भेज देता हूँ अभी आपको ये,
ओके सर.
ठीक है. ओके, थैंक यू. रिकॉर्डिंग बंद की थी हमने.